Welcome to part 3 of 3 of the Central Region Convective Warning Improvement Project's modules focused on high shear, low cape, severe weather. This module will focus on providing warning examples within high shear, low cape, severe weather events. My name is Keith Sherburn. I'll be the narrator for this module. If you have any specific questions about any of the events or materials shown here, feel free to reach out to me via email at keith.sherburn@noaa.gov. Again, this is the last in our series of modules exploring the unique high shear, low cape, severe environments. Here we'll be looking at a pair of cases that impacted portions of the southeast U.S. in March of 2022 and December of 2019, respectively. For each case, I will provide a brief environmental overview, then focus on the warning decision process. An example case from January of 2013 is shown at right. First up, the case spanning the night from March 30th to the 31st in 2022. This event featured a broad, bell-shaped moderate risk from the Storm Prediction Center's 20Z outlook spanning much of the Gulf Coast into the Deep South. The bulk of the moderate risk featured both a 15% hatched tornado risk and a 45% hatched damaging wind risk. We'll primarily be focusing on the evolution of storms from eastern Mississippi through western Alabama as shown by the black dashed square. At 12Z prior to the event, 300 millibar and 500 millibar fields reveal some hallmarks of high shear, low cape severe environments that are supportive of severe weather. First, we see a split upper level jet upstream of the region, consistent with strong upper level divergence and forcing for ascent. At 500 millibars, a sharp trough is located over the high plains, and a strong mid-level jet streak extends from near the base of the trough through its downstream side. From 850 millibars down to the surface, we see a notable cyclone centered over the upper Midwest, with a baroclinic zone and cold front extending southwestward through the southern plains, as you see here. The warm sector extends from near the low center southward and eastward through the Tennessee Valley and toward the Gulf Coast. Dew points in our area of interest are in the 60s, with some dew points around 70 near the Gulf. At 850 millibars, some southerly 50 to 60 knot flow is evidence in Louisiana and up into Mississippi. Jumping ahead to 0Z, which is right around the time of interest for our case, the strong upper level divergence, including notable diffluence in the flow at 300 millibars, has overspread the region of interest. A short wave within the broader long wave trough over the central conus has dug southeastward into the Missouri Valley, as you can see here. We continue to see speedy flow across much of the region as well, with 60 to 80 plus knot winds at 500 millibars. At 850 millibars and the surface, the aforementioned cyclone and attendant baroclinic zone have both shifted eastward at this time, allowing the warm sector to expand both north and eastward. Dew points over the southeast have also increased, with readings ranging from the mid-60s in our area of interest down to around 72 degrees near the coast. Southerly 850 millibar flow at this time in the warm sector remains about 50 to 60 knots from near the Gulf all the way up through the Ohio Valley. Turning our attention to the convective environment, I want to first reiterate that while the SPC mesoanalysis is an important operational tool for diagnosing characteristics of real-time near-storm environments, it's not perfect, particularly in these high shear, low cape situations. Tight gradients and narrow corridors of relevant fields, particularly thermodynamic fields like CAPE, might get smoothed out given the relatively coarse grid spacing of the mesoanalysis. We'll employ the fields here to get an overall sense of the environments and some potentially important trends, and that's how I would suggest using the mesoanalysis in real-time high shear, low cape situations as well. So with that caveat in mind, let's start by looking at mixed layer CAPE, SIN, and effective shear fields at 0Z. Mixed layer CAPE values here are largely below 1,000 joules per kilogram, though a localized corridor of higher values extends from near the Mississippi and Alabama Gulf Coast northward along the state line. In this region, the environment is also essentially uncapped. Effective shear magnitudes range from around 50 to 75 knots, which is more than suitable for either QLCS or supercell modes. CAPE diminishes substantially as you get a little bit farther north, with values generally under 250 joules per kilogram as you get north of the Tennessee, Mississippi, and Alabama state line. By 3Z, some further destabilization is evident across far southern Mississippi and Alabama, along with some modest destabilization across Middle Tennessee here. However, the northward extent of mixed layer cape values of 500 joules per kilogram or greater hasn't really changed substantially at this time. Effective shear magnitudes also remain largely unchanged, with values of about 60 to 75 knots in our area of interest. At the surface, and primarily focusing on analyzed dew points, we see the corridor of mid-60s to lower 70s dew points at 0Z mentioned when looking at the surface charts. Between 0 and 3Z, the analysis suggests a subtle retreat of these higher dew point values, but 60-plus degree dew points still extend through most of Middle Tennessee. At 850 millibars, a broad 50-knot jet streak is located over much of the region, supporting both low-level theta E advection and strong low-level shear. The structure of the jet does not change much between 0 and 3Z, and some of the differences we see here might actually just be artifacts of the foundational wrap trying to depict convection. A couple of key fields are shown here, the 0-3 kilometer shear vectors and the max vertical theta E differences, the latter of which are shaded. The brown and yellow shades here indicate that potential instability exists over part of the region. Recall from a prior high shear locate module that the release of potential instability is one of two processes that can lead to rapid in situ increases in instability during these high shear locate events. The other is strong low-level theta E advection. Potential instability is present over roughly the southeastern third of Mississippi and the southern half of Alabama at 0Z. This corridor does shift eastward by 3Z, but the release of potential instability might be responsible for some of the increase in mu cape that we see here during those 3 hours as well. Over far eastern Mississippi and western Alabama, there is a notable increase in 0-3 kilometer shear vector magnitudes during this time as well. You go from around 40 to 50 knots up to 50 to 60 knots. So in the context of the three ingredients method, any surge towards the east, northeast, or north would meet those line normal shear criteria of about 30 knots. 0 to 3 kilometer cape is fairly high at both 0 and 3Z in our area of interest, with values generally in the 50 to 125 joules per kilogram range. In the context of the mesovortex warning system, if we have a QLCS, the 0 to 3 kilometer cape nudger can be checked off through eastern Mississippi and western Alabama. At 0Z, the 0 to 3 kilometer lapse rates on the eastern edge of the unstable sector are also quite steep, around 7 degrees Celsius per kilometer or greater. These steep relapse rates do retreat a bit northeastward, but that's as the increasingly moist, unstable air overspreads the region, and we continue to see fairly strong 0 to 3 kilometer cape. The effect of severe hazards in environments with reduced buoyancy parameter, or SHRB, which as you may recall combines lapse rates and shear, highlights much of the warm sector in values of 1 or greater, suggesting increased potential for significant severe weather. Because this parameter was developed for environments with surface-based cape under 500 joules per kilogram, it's not as insightful for parts of our area of interest. But I'll point out that values of 1 to 1.5 extend through Tennessee and Kentucky, even into southern Illinois in this case. And tornadoes were reported in western Tennessee and southern Illinois in this event, whereas we had significant straight-line winds observed and measured in western Kentucky. So in this case, it was a success story for the SHRB, and that it was really highlighting these regions that had minimal cape, if you recall from earlier in the case. Likewise, the modified SHRB has values of 4 or greater, which is the threshold I like to use on the SPC mesoanalysis, over much of the warm sector, but a pair of localized maxima over northwestern Tennessee and northeastern Mississippi into northwestern Alabama corresponded to areas where tornadoes had developed in the previous hour and notable wind damage occurred in this event, respectively. One very useful technique in high shear, low cape environments is combining the SHRB and modified SHRB with a significant tornado parameter, or STP. In this case, STP values are near or above 1 for much of the area of interest, not everywhere. Note that values under 0.25 extend as far north as western and middle Tennessee, where I noted before that some tornadoes did occur prior to 0Z. But if you focus on areas where high modified SHRB values and locally enhanced STP values overlap, such as near the northern extent of a tongue of STP values around or exceeding 0.25, that can prove advantageous in the warning decision process in these high shear low CAPE environments. So with that environmental context in mind, let's hop over to some radar data. Okay, so let's take a look at some radar data for this particular case. Here I've got a 4-panel, upper left radar reflectivity, upper right base velocity, lower right is KDP, and then bottom left here is spectrum width. And we're focusing on this portion of the line from around Decatur, Mississippi, down through the Bay Springs area, down to about Collins, Mississippi. Zoom out just to give you a perspective on where that is, kind of south central Mississippi here, kind of near the southwestern corner of the domain that we had when we were looking through observations and mesoanalysis fields. So just getting a sense here real quick of what we're dealing with. Overall, not a whole lot in terms of bowing structure at this particular time, maybe a little bit of convex structure there along the leading edge of the line. North of Bay Springs, do have a little bit of what appears to be an inflection point here, southwest of Bay Springs, with an enhanced area of spectrum width there, which is kind of interesting. And then going down south of Taylorsville towards Collins, maybe a little bit of a slight bow there as well, but nothing immediately concerning in terms of surging areas along the leading edge of outflow here. If you just want to take a quick look along this portion of the line to see, are we dealing with a balanced or shear outflow dominant updraft downdraft convergence zone, I'd say overall we could consider this balanced based on where the enhanced spectrum width is and that reversal from inbounds to outbound velocities. And we're looking at Jackson, Mississippi here. KDGX is where our radar data is coming from. You know, maybe you could say it could be slightly outflow dominant, but I think in this particular case, especially because we're dealing with highly dynamic events, rapidly evolving situation and environment, I wouldn't be too concerned about that slight displacement there. I think this is fair to call it balanced. So let's step forward a little bit here and just kind of see how things evolve with time. And I'm going to focus on the section of the line here from about Bay Springs down through Collins. With time here, you start to see a little bit more of reflectivity dropout along the backside of the line, especially there west of Taylorsville. Looking at base velocity, really strong inbounds out ahead of the line and some strengthening outbounds behind the leading edge as well. So enhanced convergence right in that area. Looking at KDP, pretty notable KDP core there just north of Taylorsville, which is kind of coincident with you know, that heavier area of reflectivity as well to the north of Taylorsville, which is what you would expect. With time, we see that get a little bit more of a bowing structure there. That's maybe most noticeable in spectrum width, but you can also see it in velocity imagery a little bit there, and reflectivity as well. Have a more notable reflectivity core from Taylorsville up to where that KDP core is to the north of Taylorsville, with values that are quite high at this point, and continuing to see additional reflectivity dropout along the backside of the line. So a few different things that we're starting to see all coming together in this same location that could be either confidence builders or nudgers with time. So stepping ahead, a few more scans here, really starting to see that reflectivity drop out now between Taylorsville and Bay Springs. So evidence there potentially of a descending rear inflow jet. I'm going to zoom in just a little bit here too for this section of the line. Continuing to see pretty decent KDP core at the lowest elevation tilt there. And if you tilt up, you actually see a couple distinct areas of enhanced KDP on either side of Bay Springs at this particular time. Somewhat of an interesting velocity structure there farther aloft too, or potentially some localized areas of enhanced rotation there at the current time. One thing I've noticed too in stepping through the velocity imagery, and I stepped back a few scans here, You occasionally see these localized enhancements on the lowest tilt, and lifting up along the line towards the Bay Springs area. There's one there just east of Bay Springs at this given time. Another maybe right through here about 5 minutes later. It's unclear exactly what these surges are, but I've seen them in a lot of high shear low CAPE events in the past, and they can often precede mesovortex genesis or maybe even tornado genesis. So that's something to keep in mind, even though not strictly a confidence builder or nudger. But as you get here to about 0020, and especially as we get closer to, say, 25, 27, 29, what develops here with time is this KDP break east of Bay Springs. You can see it right there with the red square and also with my cursor. You're starting to see maybe a little bit of break in reflectivity there as well, but it's very noticeable in KDP. And some recent research has identified these KDP line breaks and KDP drops as essentially replicating the same mechanism as what you get with a reflectivity dropout and a line break in reflectivity, but they can occur a little bit earlier. So these line breaks in KDP can often be precursors to line breaks in reflectivity. And as a result, when you consider that in the context of the mesovortex warning system, I would call this a line break at this particular time. And I would treat it accordingly when I'm deciding what sort of warning to issue in this particular case, if we're going to issue a warning at all. And just thinking about the three ingredients method, we have this bowing feature here. It's quite a bit more noticeable now east of Bay Springs. The updraft downdraft convergence zone is still pretty well balanced in this section of the line. And as we talked about when we were looking at the environmental data, the 0-3 kilometer shear is so strong at this point that pretty much any surge towards the east or north or northeast would be consistent with that threshold necessary based on the three ingredients method to start looking into a warning potential at this time. So ultimately, I think this will be a good point to make a warning decision. I do want to just tilt up real quick to see if anything else is noticeable. Still have a pretty broad area of convergence rotation through here. So maybe hinting at the development of a mesovortex. I mean, you could argue that you might have an area here that qualifies as a mesovortex. You have inbounds around 20 to almost 25 knots and outbounds about 30 to 35 knots, pretty close to one another. So you may be able to consider that mesovortex at this time as well. And just taking a few steps back and looping back through here, you are also starting to see these reflectivity tags lifting up along the line, not necessarily interacting so much with the bowing section of the line, but they're awfully close. So that's definitely something to keep in mind. So given all this, let's go ahead and make a warning decision at this time. Okay, so here I've pulled up the CWIP QLCS Warning Recommender worksheet, which you can always find on Google Drive and make a copy for your particular cases. Here we're going to assume that the three ingredients are being met, as we talked about. Updraft, downdraft convergence zone is pretty well balanced. The 0-3 kilometer line normal shear criterion is met for sure in this circumstance along the portion of the line we were looking at. And finally, there is a bowing or surging section of the line there as well. So let's just check off the different features that we are identifying. We did see that descending rare and flow jet and reflectivity drop, talked a lot about that. Didn't really have an enhancing surge or bow at the time, although that's something to keep an eye out for. We did have a line break. Again, this was largely in KDP at the warning decision time, but I'm going to go ahead and consider that a line break because you can often see that in KDP before it shows up in reflectivity. Didn't really have any of these other features just yet. In talking about the environmental data, we did see that the 0-3 kilometer CAPE was above the threshold of 40 joules per kilogram over much of the region. Let's say as well, we talked a little bit about the mesovortex that may be developing at the current time. It wouldn't meet the criteria for a strong mesovortex with VR of over 40 knots, but let's say that we did have that mesovortex of about 25 knots or greater. It looked like from what we were sampling, it could be close to about 30 or maybe 35 knots at the given time. So the recommendation here at this time would be either a severe thunderstorm warning with a tornado possible tag or a tornado warning itself. And as we've talked about in previous training materials, there is some overlap built in between the severe with TOR possible and the tornado warning, and we're falling right in that range now. There is some inherent subjectivity, so it really depends on the events and the confidence of the forecaster at the time about in terms of whether they would rather go with that severe thunderstorm warning with tornado possible tag or just go all the way to tornado warning. For the purposes of this simulation and this exercise, let's go ahead and stick with severe thunderstorm warning with tornado possible tag for now, and then we'll discuss what could maybe tip us over to a tornado warning as the event continues. So we've made our warning decision at this point. Let's say that we went with a severe thunderstorm warning with a tornado possible tag just in this hypothetical situation. And going forward here, given what we already know about the environment, about the evolution of this section of the QLCS so far, I want you to be thinking about what would tip the scales enough for you to issue a tornado warning, if anything. We may find that as the storm evolves, it starts to diminish in intensity. Maybe we don't really have features that lead us to ever making that decision about a tornado warning, but maybe we do. So let's go ahead and step forward a little bit here, and we're going to follow this section of the line that, again, is just east of Bay Springs, heading towards Paulding, Mississippi, and see what happens. So remember, we have this apparently descending rear inflow jet. We have these reflectivity tags out ahead. Let's see if they start to interact with each other at all and what exactly happens. So stepping forward here, there was an interesting feature here. It's hard to tell if that was a legitimate velocity signature or not at this point. We could jump over to CC, kind of have some bad data there in CC. Overall, there's a little bit of vertical continuity there, but it was so brief as I stepped forward, it's hard to know if that was legitimate or not. But I did want to point it out that we see it. Continuing to go forward, starting to see this pivot a little bit more now. So I think we're not just dealing with a surge or bow. You're seeing an enhanced surge or bow in this area now near Paulding. That KDP line break is a little bit wider than what it was before. Starting to see maybe some hints of that reflectivity break going all the way through near Paulding. I'll step up in elevation a little bit, not quite seeing it as much there, but you definitely see evidence of that rear inflow jet. Again, the radar is off to our west-northwest in this case, and see really strong outbounds near Paulding, coincident with that dropout in reflectivity and also dropout in KDP. So no doubt that there's a rear inflow jet impinging on the front of this line here. In terms of spectrum width, one thing I like to see if I'm going to be anticipating or observing mesovortex genesis is the breakdown of just a cohesive line of enhanced spectrum width into either elliptical or a circular maxima of spectrum width, and I'm not quite seeing that just yet, but overall very clear that you have a really nice convergent rotation signature here near Paulding. So this is the area to watch, I think, going forward in terms of potentially issuing a tornado warning. Stepping forward a little bit more, look at how much this outflow boundary has pivoted now. I mean, it's almost west to east here, northeast of Paulding. So you're really seeing that start to wrap up. It's evident in velocity too. Really strong inbounds to the northeast of Paulding, to the east of Paulding, a little bit stronger outbounds. So I'd certainly say you have mesovortex genesis effectively ongoing at this time. I tilted up, but we don't have any new data at higher tilts just yet because we're in sales 3. But nonetheless, let's step a little bit farther forward. And maybe starting to see a little bit of that elliptical or circular enhancement in spectrum width there northeast of Spalding. Still don't have any new data farther aloft. At this point, 0047, maybe a little bit tighter rotation there near Paulding. And if you look at reflectivity, you're definitely seeing that reflectivity drop out, and it's starting to wrap in, it looks like, to the east of Paulding at this point too. If I tilt farther aloft, I do have some new data now, really strong circulation and couplet a little bit higher up. But this reflectivity dropout is really starting to wrap around the main updraft and downdraft now at this point. So I'd say you're probably dealing with imminent tornado genesis even at this point, with how significantly that rear inflow jet's really starting to wrap around in there. Go a little bit farther here. I'm going to switch this over to correlation coefficient now, because we're at the point where I'd really be starting to get concerned about tornado genesis. That couplet's kind of weakened at this point, but let's just kind of carry it through and see how things go. No, and so we're continuing to get this reflectivity dropout at this point between Enterprise, Stonewall, and Basic. And there you start to see really pronounced couplet. That looks like that is probably a tornado at this point. All right, so just stepping back to the beginning here, this was our warning decision point. Did you decide to issue tornado warning at any point? Let's step through here and just kind of take a look at where the reports were. There were some wind damage reports between Mize and southwest of Base Rings. What is that? That's Taylorsville. So there were some wind reports down by Taylorsville, generally power lines down, trees down. But stepping forward in our section of the line that we were really concerned about, here's about 10 minutes after warning decision point. Currently, no reports. Stepping forward a little bit farther, here's 15 minutes after warning decision point. No reports just yet. This was the time, though, that I was thinking, man, this is probably, if I didn't have one out before, I probably would have gone with a tornado warning at this point, just given how much that leading edge was starting to pivot and how strong the convergent rotation was at that point northeast of Paulding. So stepping forward another 5 minutes or so, nothing yet. So here we are 25 minutes after warning decision point, nothing in terms of reports. Here we are, half an hour or so after our warning decision point. There's a report near Stonewall. Of course, the timing of this may not be quite exact, but 2 trees blown down in Stonewall. Some roof damage as well, and then step forward another minute and you have tornado. Weak tornado, but a tornado nonetheless there near Enterprise, and pretty subtle velocity signature there overall. Some additional damage downwind of that, and then here's another one. Here's the other tornado. This one again, winds of 90 miles per hour, but nonetheless a tornado. And here, if you had issued a tornado warning with that initial warning, you would have been looking at over 35 minutes of lead time. If you had issued it around that second time that we were really starting to look at that convergent rotation, you would have had about 20 to 25 minutes lead time. So pretty good overall. And just kind of taking a look at how this persisted. We're getting in the purple haze now in terms of Jackson's radar, but there was an additional tornado downwind. So this just kind of produced some cyclic tornado genesis along its lifetime. A couple more reports of tornadoes here. So that was an EF1 tornado as you're getting close to the Alabama state line there. So this event did produce several different tornadoes. had cyclic tornado genesis from south central Mississippi up through west central Alabama. You can see farther north along the line too, there were some additional tornadoes. So a fairly prolific QLCS in what appeared to be a borderline high shear low cape environment in terms of plenty of shear and around 500 to maybe up to 1,000 joules per kilogram of mixed layer cape in the southern parts of the domain.